Okay, this is for this lamella exercise. Okay, here the cluster, you have the mesh, send it as the input, and then you specify the length strength, the strength for the boundary edge angle, for the internal edge angle, I think. Okay, and then ny together with the mesh, because you want to show it, and then also the grep. Okay, connect to the solver. Okay, you retrieve the mesh and then reset it. Okay, turn it on. We go to perspective view, and it should act like, okay, a lamella. Okay, and you can still adjust the behavior of it by, I would say, you are not going to change this length strength, but for the boundary angle and the internal angle, if you make it larger or smaller, then somehow you change the structure property of this lamella. Okay, and we can go on for more complicated object. So for example, this exercise, okay, initially it's like this, but then I use a string to pull the two diagonal of it, and it tries to balance itself, and then until it becomes like this. So you get this saddle shape, which is a hyperbolic surface, and we can adjust the length of it. And you can compare the result to see if it is similar to the grid that I passed to you. Okay, I think it is kind of similar, not exactly the same, but kind of similar. Okay, how I did it. So after you have made this cluster, which is one? You see this cluster. Okay, you can go on to make more and more complicated simulations. Okay. And this part, I just try to create the mesh. So first is this lamella, one single lamella, and then I use this kind of linear array. So I create a set of it, and we can still adjust the size of the lamella. For example, 16 and 2. Maybe I want to reduce the width of it. Okay, now it becomes like this. And then for the other direction, I create another set. So now you make a grid of it. Find the bounding box, because I want to find the 4 corners so that I can add strings. So one corner, this one, and the other one on the top. For the opposite corner, I use the bottom part. So I use a bounding box, and there are 8 vertices for this bounding box. And with this component, you get all the 8, and you just try to figure out the diagonal corners of them, and then you create 2 line segments, okay, across, and then calculate the length, and then use the length to set the line length constraint. And you use a slider between 0 and 1 to control the proportion, the amount you want to pull closer these 2 opposite vertices, and for both of these strings, so you can control it. Of course, you can still grab it, okay? But sometimes when we make our design, we want to precisely locate some critical position onto the structure that we are designing. Okay, so grabbing is maybe only for fun, but for our design work, we need to precise control of it. So there are different ways, okay, but basically what we do is to add constraint to it. Okay, and what is this? Okay, this is grab. Okay, you can also control grab. For example, you can turn it on and off, and you can change the strength of it, or you can change the effective range of it. Because when you want to grab something, you have to move your cursor to somewhere near the vertices, okay, and the range will set up the effective distance. Okay. So what else? And then you want to show it. Okay, and this is the cluster. So you see, it's not only simulating one mesh, but simulating a set of meshes. It is also possible that you connect all these meshes into one mesh. I haven't done that yet, but perhaps it works. I'm not quite sure, but maybe it works, but somehow with different behavior. Okay, maybe let me try it. Okay, let me try to do that. Now we have a set of mesh, right? So before we start to do the simulation, I try to join all the meshes. Mesh join. Okay, when you join the mesh, in many cases, I would also weld. Right now it has 612 vertices. After I weld it, it has less vertices. Not much less, but still has less. This one is not really necessary, but I think it's okay. And now it is only one mesh instead of a group of meshes. Let me see if it works. Takes a while. Wow, how come? What is wrong? I don't know. Okay, I think I know. Now it has a lot of edges. And inside this cluster, actually it does some computation. Doesn't work. Okay, doesn't work, but maybe I can fix it afterwards. Okay, but not now. Okay, so this part I will finish here. If you turn on, if you open this cluster, you will see that somehow I didn't do it exactly the same way as I have just showed it to you. Wow, sorry, I shouldn't do this. Okay, anyway, for this part, we stop here. Okay, if you are interested in figure out what I'm doing inside this cluster, you can open it and try to take a look. And if you have questions, you can come to ask me, no problem. Okay, so let's go back to the Moodle. So this is, you see, this is from, how do you call it? Gecko, right? Gecko. And this is the foot of it. And you see, this is the lamella structure. Okay. Okay, and this is the exercise I want each group. Every group will make a 1/5 scaled model of the asymptotic grid shell structure. The size of the model will sorry, will be about, I mean, for my rough estimation, 50 times 50 times 50 centimeters. The model will be the structure that support the envelope system that you are going to design and model for the final project. Okay? And these are the two drawings. First one is the model. I think I have shown you last time. And the second one is the DWG file, which is used as the shop drawing. So actually, they have already produced the part, and the part has already been shipped to Hong Kong. So right now, the Hong Kong University, the professor Ike Schlin and his student is examining the parts, and then they are going to build one structure over there, and we are going to build ours here in our campus. Okay, so let me take a look at this file. So we open it. Okay, the first one is, no, not yet. Okay, this is the file. Okay, you have to turn on and off these layers to show whatever you want to see and whatever you don't want to see. Let me turn off the construction planning, network, the input, and yeah, this part I have to move it to some other layers because I don't want to see them. So maybe construction planning, lamella. All right. Okay, now this has disappeared. And now I have to turn on the thing that I want to show, surface model. Okay, so this is the structure that we are going to build. So first we have this outer frame, right? And then the inner part consists of this lamina grid shell. Okay. And there are network, like the center lines of this lamina strip. Okay, this is the center line. Asymptotic 1x single. So these red lines are the grid, calculated grid lines. They are located exactly at the center of each group of lamina. And for each lamina, there are two, okay? Two lamina parallel as one pair to make the grid. Okay, and this red line is at the center. If you mirror this red line, then you get the other set. Okay, right now it shows only one thing. And this X1X double clean shows the both the lamina. Now it's not so easy to see here. Okay, but you don't have to worry about that because the shop drawing has been created. Okay, it's calculated by some grasshopper programs. Okay, so this is the surface model. And if we go to another drawing, which is a DWG file, but we can always get it. Large object, millimeter. Oh, by the way, you have presentation, right? I should let you. Sorry, I forget to do this. I should let you upload your files, right? So let me create one more homework for you so that you can upload your files. Okay, so please upload your file here, presentation for case study. Okay. And let me go back here, and then this time I'm going to import the AutoCAD drawing, and I'm going to explain to you the shop drawing. And which is this one, AGS. AGS, I think, is the name of the company which is going to make it. And this is fabrication. HY is the abbreviation of the one who make it. He's Hou Yang. Perhaps some of you know him. His Grasshopper program actually analyzed this 3D model and create this shop drawing. So we import it to Rhino. Okay, don't worry about these Chinese characters. You don't need to understand them. Okay, so these are the lamina pieces. Okay, and maybe, I mean, for a scaled model, some details you don't need to worry about that. Okay, but this slot, you have to slice 2 pieces of lamina into it. So actually, for scaled down model, you don't need this detail. Maybe you simply need to cut the 2. Cut them. Use a pair of scissors or a laser cut. And then you can slice lamina for the other direction into it. Okay, you get it? So you need one cut here, the other cut here.
What is the reason?
So
What is the reason for the holes in here?
for the holes, okay, because they have 2 parallel lamina going, twisting and bending. Okay, so they need some other object to maintain the distance between these 2 parallel laminas. Okay, and these holes are for some metal pieces to hold it. Okay, you will understand it after the shipment, after we get all these pieces.
Okay, but we
Okay.
don't need
Right now it's okay, but for the scale down model, we are not going to model this kind of details. Okay, so this person Hou Yang, he has been also teaching in our school, but right now he works for the company. He suggests that we can simplify the whole thing. We need only to cut the outline of this lamina and then make 2 cuts here, and here. You don't need all this detail. You just need one cut to going from here to here. and the other cut from here to here at exactly the same position. Okay, and then you will be able to slice the other set of lamella from another direction into it to make the structure grid. Okay, and we have to use the kind of paper. I would suggest, I mean, not even this thick. Maybe the kind of paper for like a watercolor painting. Maybe something like that. Okay, but for the boundary, we need a strong structure for the boundary, and the sharp drawing is here. Maybe we use like a 1 millimeter or 2 millimeter thick paper, okay, to cut. You can laser cut them, or you can cut it by hand. I think this is not too difficult. Yeah, we can laser cut it, okay. And I would say each team will make one model because you are going to design your own surface structure, okay, and put that onto the grid shell model that you make in 1/5 scale, okay. Okay, so roughly it's like this, and I hope that if we can complete this model in, I don't know how much time I spent. Do you think you can do it in 2 weeks? In 2 weeks? And you can cooperate. I mean, you don't have to compete with each other. You can cooperate, right? But we need one model for each team. Okay. Okay, you can cooperate and then you can share your work. For example, if you make the laser cutting, you can make enough for all teams. But every team, you have to actually assemble the model yourself. Okay, maybe you can organize yourself, and then some people, if you are willing to provide your service, then you can, and you are also familiar with the laser cutting machine, then you can cut many copies. Okay, yeah.
Can you ask in the round if there is anyone with a familiar with laser cutting who's already did it here in the school? I don't want to ask everyone. Is there?
Laser cutting machine, I think, should be no problem. There are some. Who is familiar with laser cutting machine? You? Are you familiar with laser cutting machine?
I just use it once.
Or use it once? And also you can find, you can ask, Vector Lee. He has courses teaching robot arms. He's an expert on laser cutting machine. And I don't think it will be a problem because we also have assistants for laser cutting machine. So I think you need to register to someone, okay? And there will be assistant, and you can show him the shop drawing, okay? And then depending on what kind of material that you want to use, you set up the intensity of this laser, okay? And yeah. Maybe you discuss with each other, right? To organize yourself. Okay. For people who are not familiar with, you can learn. Okay. And for people who are good at it, you can provide your service, and you also establish your social relation. Okay. You become a very respectful person in this institute, right? Such as Hong Yi. Okay, he's very respected. You know, have you got the result of this competition? You just did your presentation.
Yeah.
You know the result?
Which competition?
那个什么朝向未来，什么狂想创意狂想。
Oh, not yet the result.
Not yet.
Not yet. But I know.
Okay, I think it's not a big deal. He won the first prize.
Oh really? Thank you.
How much was the price?
Okay, it's fair.
100,000?
Really?
I'm not sure because long time ago it was 100,000.
Okay.
But I think somehow they, if they don't have enough budget, then they cut. I don't know how much it is.
Okay.
Okay. Okay, good. It's very competitive. It is very competitive, actually. There are some other team from some other university. They are also very, very good. Okay. Okay, so this is for the frame, has to be very strong. And these are other pieces. And for the scale down model, maybe you don't need these pieces. Okay. Okay, maybe I assign some work. Zhenting and I always forget his name. 另外一位从高雄大学来的。想不起来你的名字。啊？你的名字是什么？啊？中环。Okay, 郑言中环。I want you to study this. Okay? And then think of the kind of problem that we may need to resolve, and using what kind of material, and then you can suggest to everyone. Okay? Or if anyone is interested in working on this, okay, you can work with them and then try to figure out, and we can share our experience and knowledge. Okay. Personally, I'm not the expert of making this model. Okay. Okay. Because I have never done myself to do something like this. Okay. But some of you have a lot of experience. Okay. Anyway, I hope that before we actually build the foresight model, we need to study using scale down model. Okay, so that we'll be able to work on the larger one without getting into trouble. Okay, so that's it. And now it's time for your presentation. Okay, we have to do it very quickly. So, have you upload your files?
I mean, they say that we were going to present last class.
Okay.
I don't know. I will watch the video to do something.
Anna, okay, would you like to make your presentation first?
Oh, file. Where is it? The one that she sent me.
Yeah, here. Okay, good.
We just introduce what we've done on this.
We can share first the first ones or no? We can just show.
Show and tell them what is our concept.
Yeah.
Okay.
But I guess why me? He should speak. Oh, we need to turn off the light.
Yeah. Can you turn off the lamp
This only
for
goes
the
down.
first row? Yeah.
So there's
The
no way
switch,
to
there's a mark
go to
on the
next.
switch. You
No,
just need to
because
switch.
this
Yeah,
PDF
thank
not
you.
PowerPoint.
Thank you. And this facade, first we make a flat rectangle surface and divide the surface by U and V counting. And then
Just to explain first that first we had a lot of different facades.
yes, we have a lot of different facades.
Yeah.
And we just
We tried all of them and then we
select the concept we want to
Yeah.
do, and then we combine our concept into one facade.
Yeah.
Yeah, and this is the first type is this one, and
This is too slow.
this one create
Okay. I'll use the mouse.
mouse.
Yeah. Okay. You
Okay.
tell me when to.
Okay, this one is the first concept, first facade, and second facade is like a twist
Strip.
strip. It's strip, and we create just one rectangle and twist them, and just arrange them into the facade, and then next, and this
The
is
third one.
the third one is a wave with strips, and I think
So you did all of them.
yeah, I did all of them, and I just pick out one, pick out two kind of concept and make
Together. Yeah.
and together, and
Okay.
yes.
So we're showing all the first ones.
Oh,
Wow.
I think we just show them
I skip?
our result.
Okay.
Yes.
So this is the fourth one.
Yeah, this is the first one, and this is triangular pattern, and this is the rectangular pattern, and I think it's a random angle on the facade, random angle panel on the facade, and
Sorry, can you show the random angle? Where is the random angle?
This one.
this one,
Oh, okay,
the
okay. So
red,
each
red,
of this small thing,
yeah,
you
the small
rotate it in
pieces,
different angles.
yes,
Okay.
Yeah.
and we combine the um, twist twist strips
Okay.
and the
So this is the.
random
Yeah.
panel into one facade.
Yeah. So this is our final, right?
Yes, this is our final.
The
Next,
combination.
like this. And
But this is not random.
yeah, this is not random.
This is from some image.
We use pool curve, and
Okay.
we want to know the distance between point and the curve, and use this component and knowing the distance of each panel,
Yeah.
and we just use this distance and turn into the angle to each panel.
By using these curves, right? Yeah.
Yes.
The twisting, is it continuous or discrete?
I think it's continuous.
Continuous?
Yeah, it is a continuous line, continuous curve to influence
Uh-huh.
the angle we rotate them.
Okay, but then each panel is separated.
Yes,
It's not a continuous lamina twisting.
it's separated. We just create one panel and just put it into the facade,
Okay.
separated put it, and,
Okay.
And
and
that's the result.
the result.
Yeah. And this is the
This is
script.
how we create them. And this is a rectangular panel, and we just use Iridium to um, just put into the facade. Okay,
Okay.
that's all right. That's all.
Okay.
Okay.
Thank you.
Any questions or suggestions? Okay, very good. Thank you.
Thank you.
Now we can move on. 好，你们没有时间了吗？现在是几点？3点多。OK， 好。OK， 他必须要先走，对不对？